This video deals with Chapter 2, Section 3, and Section 4. So Chapter 2.3 and 2.4. They both deal with analysis models, so I'm lumping them together. So when we're talking about an analysis model, we're talking about a common situation. And because we've looked at this common situation, we either know how to deal with it or it's similar to something that we know how to deal with. It might be a single object and its behavior. Or it might be an object interacting with the environment. If we encounter a new problem, then we want to ask what's important about it and how is it like something we've seen before? So what I'm going to start with is Black Escalade is traveling south on 25 through the snow at night. Traveling at 40 miles per hour. How long would it take to reach Berea from Richmond? All right, so the first thing we want to talk about, we're now into 2.4. 2.3 is pretty much just looking at a constant velocity problem, and that's our example that we're using here. So if you're following in section 2.4, the first thing is to conceptualize. And we've already talked some about how we model situations, and this is the majority of it. So the first thing you want to do is think about the situation and try to understand it. All right, so let's read it again. A Black Escalade is traveling south on 25 through the snow at night. It's traveling at 40 miles per hour. How long will it take to reach Berea from Richmond? Right, and I don't know what that distance is right now. Let's assume that it's 15 miles from whatever markers we're using. Right, we might use the center of town or the city limits or whatever. All right, so as we've said before, the first thing we want to do is draw a picture. So, I could draw a map here with Richmond, and we have a car traveling south. And we know that Berea is down here at the south somewhere. The next thing, let's see, draw a picture. And we want to look for keywords. The keywords are typically things like at rest, meaning that it's not moving and it's not accelerating. Constant speed, constant acceleration. It comes to a stop or it starts from stop, those kinds of words. Is there anything like that in here? Well, we're told that it's traveling at 40 miles per hour. It doesn't explicitly say constant, but I think you have to assume that here. So I'll just put a note there. Constant speed. All right, the next thing we want to do is what is asked. I clicked on it. Well, we said, how long is it going to take to reach Berea from Richmond? So we're looking for a time. And common sense check. So we haven't found our answer yet. So at this point, we're looking for a pre-check, right? What do we expect? Do we expect hours, minutes? Don't know, right? But it's not going to take days. It's not going to take a minute. You know, we're talking like fraction of an hour, I'll say. Would be my reasonable time value there. All right, so after the conceptualizing, we want to categorize. This is a little different organization than I've gone through before, but this is the way the book breaks it down. So if you're reading through the book, I'm going through it here for you the way they do. And I misspelled category. Categorize. All right. The first thing you want to do is simplify, right? And that's where your model comes into play. Right, so I drew a picture of my car driving down the road from Richmond to Berea. So now we're going to do our simplification and V is 40 miles per hour. And delta X is 15 miles. Right, so here's my simplified model. Instead of my picture of my car driving down the road, I now have, it doesn't matter that it's a car, I just have a point to represent my car, and it's going to move 15 miles at 40 miles per hour, reasonably in a straight line. All right, so the next thing that the book says is ask yourself, is this a substitution or analysis problem? Right, by substitution, what we mean is what you might just call your old plug and chug problem, right? You just take your equation, plug in the numbers, and you got your answer. Analysis means, you know, you're going to have to put extra thought into it. This example, I would say, is pretty much a plug and chug, right? We know, we said that this is constant speed, and we're asked for the time of travel. Our constant speed equation is distance equals rate times time. We're asked for the time of travel. So I'm going to solve for that. The time of travel will be the distance divided by the speed. And we just plug and chug, right? What did I say? We're assuming 15 miles at 40 miles per hour. Well, I guess I'll write it down here instead of up there, right? But in the denominator of the denominator, it'll come to the top. And we're left with some part of an hour. Let's see, that would be 3/8, right? 3/8 of an hour. So that fits with our estimation, right? So that brings us to, well, I've done the next part. This was analyze. All right, that's your, do your math. Right? We made our model, we identified what type of problem it was, and then we did our math. So now we're at finalize. And the text draws a lot into finalize here. Not only are we asking you to check your units and check it against your expected value, and ask, does it make sense? Right, those are what you would normally do at the end of any problem, right? We expected it to be a fraction of an hour. We ended up with 3/8 of an hour. And that makes sense, right? That's a reasonable time. But I think it also is important to reflect on what you're doing. How is this alike or different from other problems? You know, and what are you really taking away from it? We did another problem where we had a constant acceleration, right? This one's at constant speed. There's a 0 acceleration, so there's a difference there. But we still had a car driving down the road, right? So it's a similar setup, but the way that we analyze is different because of the way that the object is acting, right? That fact of a constant speed or a constant acceleration gives us a different analysis. All right, let's stop there for this video.